Here are solutions to homework set number 2 for ECE 321. Due to snow days, this is kind of a short assignment. The first problem is giving a thermistor that has the following resistance versus temperature relationship. Come up with a circuit that linearizes it. Now, if you plot temperature versus resistance, this is highly nonlinear. What the linearizing circuit does is I add two resistors, kind of like this. So here's your thermistor. This one is RA. Here's RB. Find RA and RB so that the resistance is kind of linear between -20 and +20 Celsius. So we go temperature and resistance. At -20, it's going to have some resistance. At +20, I'll have another resistance. I want the resistance at 0 to be halfway between the two. So one way to do that is to use fmin search. I'll first come up with a function where I'm going to guess RA and RB. I'll calculate the resistance at -20, 0, and +20 Celsius. Find the impedance of the circuit. I'm calling that Z. And what I want is the impedance at the midpoint to be halfway between the two endpoints. And return the sum squared difference between the two. With fmin search, I can sit there and tell it, optimize this function. Here's my initial guess. Keep going. And here's what I came up with. What I'm looking for is the error 0, and these two are meaningful. For example, one valid solution is RA equals infinity, in which case the resistance is just RB. That works, but it's not useful. Another solution is RB equals 0. That shorts this out. That's also linear, but not useful. Find a solution where RB isn't 0 and RA is not infinity. This is one possible solution. If I check, I can plot the resistance between -20 and +20 Celsius. Actually did -25 to +25. Calculate the resistance, calculate the network's impedance, and plot it. And what you see is that -20 right here, +20 over here, and the middle. These three wind up on a straight line, and there's a little bit of bow to it. Kind of looks like this. But at least the two endpoints and the midpoint form a straight line. So it's pretty much linear. The disadvantage of this circuit is I have a smaller spread in resistance. That's problem 1. Problem 2 says, okay, now that I have a linear resistance, come up with a circuit that outputs 0 to 5 volts as temperature goes from -20 to +20. So here's the impedance at -20, and the voltage from my voltage divider becomes 5.7 volts. At the other point is 4.7 volts. So I want this to go to +5 volts. I want this to go to 0 volts. So the gain I need is change in output over change in input. I need a gain of 5.2. It's a negative gain because as the input goes down, the output goes up, meaning connect to the minus input. And I want the output to be 0 at -20 Celsius. I want it to be 0 when the input is 5.25 volts. So there's your offset. So this circuit should give you a voltage that goes from 0 to 5 volts as temperature goes from -20 to +20. And that's homework set number 2.